Find the values of the six trigonometric functions. Given a right triangle, we can use an angle such as theta to find the six trig functions of theta. Knowing two sides of a right triangle, 3 and 4, before we find the trig functions, we need to know all three sides or the hypotenuse of the right triangle. Using Pythagorean theorem of a squared plus b squared equals c squared, 3 squared would be 9. Adding to that b squared is 16 would give us the value of c squared, or the hypotenuse. 9 plus 16 would be 25. And taking the square root, c would equal 5, or the hypotenuse of the right triangle would be 5. From here, we can find the six trig functions. The six trig functions again are sine, cosine, and tangent, and also cosecant, secant, and cotangent. If you remember from previous math classes, sine of theta, sine is opposite over hypotenuse. So using the angle theta, opposite would be 3, and the hypotenuse would be 5. So the sine of theta would be 3 over 5, or 3/5. Cosine of theta, cosine is adjacent over hypotenuse. Adjacent would be the sine next to theta over the hypotenuse 5, so cosine would be 4 over 5. Tangent of theta, tangent is opposite over adjacent. Going opposite of theta would be 3, and adjacent to theta would be 4, so tangent would be 3 over 4. For the other three trig functions, cosecant, secant, and cotangent, we could use the same right triangle, or we can also use the answers that we found of sine, cosine, and tangent. Cosecant, if you remember from previous sections, is the reciprocal, or 1 over sine of theta. If sine is 3/5, 1 divided by 3/5, or the reciprocal of 3/5, would be 5 over 3. So cosecant would be 5/3. Secant, similar to what we did with sine, cosine would be the reciprocal, or 1 divided by that fraction, so secant would be 5 over 4. And last trig function, cotangent, taking the reciprocal of tangent, cotangent would be 4 over 3, or 4/3. And those would be the six trig functions given the right triangle. Find the value of x by using a trigonometric function. Given the following right triangle, one side is labeled as 10, the other side is x, and a degree is also labeled as 30 degrees. Using one of the trigonometric functions, we can find the value of x. Looking at the given information from the angle, we know the opposite side from the angle is what we're looking for, and we also know the value of the adjacent side. So using the opposite and adjacent sides for trigonometric functions, opposite and adjacent would be the tangent function. If we take tangent of 30 degrees over the adjacent, or in this case x over 10. Solving for x, we can multiply both sides by 10, and we'll have 10 times the value of tangent of 30 is equal to x. This will be one possible answer you can leave. If you wanted to further simplify, you could use a calculator for the tangent of 30, or you could also do the unit circle for tangent of 30. Using a calculator, 10 times the tangent of 30 would give you the decimal of 5.8. So looking back at the right triangle, the the distance of x, or the length of x, would be 5.8. Second question, and last question for the section. Looking at this triangle, we're given one side of 32. We want to find the hypotenuse of the triangle, which is x, and the angle this time is 23 degrees. Looking at the angle given, we know the adjacent side is 32, and we want to find the hypotenuse. So having the adjacent side and the hypotenuse, the trig function for that would be cosine. Taking cosine of the angle, cosine of 23 degrees is equal to, cosine is the adjacent over hypotenuse, or in this case 32 over x. To solve for x or isolate x when it's in the denominator, one way to do so is to multiply by x to cancel out the denominator, and multiply the opposite side by x also. So rewriting the question, we have x times the cosine of 23 degrees is equal to 32. And last step, to get x by itself, we can divide by cosine of 23 degrees. And we'll have x equals the fraction 32 divided by cosine of 23 degrees. And again, if you wanted to, you could use a calculator to find the cosine of 23 degrees. 32 divided by the cosine of 23 degrees is equal to 34.8. So looking back at the triangle, the length of x, which was the hypotenuse, is a distance of 34.8.